Hey everybody, check out this recent thrift store find that I got. This is a 0.7 cubic foot Haier, or Haier, however you pronounce it, thermoelectric wine cooler. Now of course I'm not going to be using this to store wine. I'm going to be using this as a mini fridge. So anyways, I'm just going to look at the specs. Here's the back panel. Here's the specification label. Tells you it's thermoelectric wine cellar. It's a model HVUE B06BBB. Capacity is 0.7 cubic feet. Takes in 115 volts, 60 hertz. Has its own built-in switch mode power supply. Pulls 0.95 amps out of the wall. 70 watt Peltier device. Peltier, however you want to pronounce it. Weighs 18 pounds. I don't think that's correct because this thing does not seem to weigh 18 pounds. And it gives you the dimensions right here. So anyways, pause to view specs. Here's a closer look at the circuit diagram it even gives you. This diagram is for the built-in power supply. I find this pretty neat that they offered to give you this information. Of course, Gina Deluxe, made in China. And you notice I got the back panel off, and that's for a reason. This cooler does not work. And that's why I got it for 10 bucks as is a local thrift store. Let me explain what's going on with it. So basically it was plugged in at the appliance test area in the thrift store. I'm guessing somebody tried it to see if it worked or not. And it does not work. The fans run, both the evaporator fan and the outside cooling fan, they both work. This LCD display was working, showing the internal temperature. It has an internal light that works too, but it was not cooling. So it's either the power supply board or the Peltier module or thermoelectric cooler. So let's go ahead and swing around and have a look at the back. Well, before I continue on, this is actually a return to Walmart. And it was returned not too long ago, Wednesday, July 25th, 2012. And it's funny enough, there's a Walmart located across the street from this thrift store. So I'm assuming that Walmart didn't want to trash this thing, they want to donate it to the thrift store. Hopefully somebody would make some use out of it. So, anyways, here's a look inside the back of this thing like I was saying earlier. Here is the built-in power supply. It's a switch mode power supply. Takes in your AC right here. Has a ground lead right here. And here's where everything plugs up. The thermoelectric module is wired in right here. The LCD display was plugged in right here. The temperature control was plugged in right here. Yeah, let's go ahead and have a look at that specification thing again. I did some troubleshooting with this thing, just for the heck of it. It tells you right here that when you're looking at the power supply in this orientation, the connectors are in this order. As I showed you, the LCD display is up top, cold sink fan below it, followed by the thermoelectric module, which is actually wired in right there like I showed you earlier. Then we have our hot side fan, an empty connector, and a temperature adjustment, which, funny to note, it's not exactly that way, but I found out that the LCD display runs on 5 volts. It's pretty typical for those kinds of devices to run on 5 volts. Because I wired up to a power supply on 5 volts and it came on just fine. And at first I figured that, seeing this thing has a green wire coming out that plugs in right here, I was thinking possibly that this temperature control module send a power on signal to this power supply to power on the 12 volt side of things to get the thermoelectric module running. Or it just, it probably had the thermoelectric module on a separate 12 volt supply. Not very sure. So I wired that up to a TEC power supply. I run the LCD display temperature control module on 5-volt standby rail, and I ran this to the power supply's power on connection. Basically what this does, this shorts out the green connection on the ATX power supply and tells the power supply to come on. And unfortunately it didn't work exactly that way. Nothing got hurt though. I mean, the power supply is fine. All the components in this thing are still fine. So it's either this power supply board or the Peltier module. I'm already going to run this off of a computer power supply to begin with, because I'm not sure how good this power supply is in terms of its amperage output. And if the thermoelectric module is bad, I can get those for really cheap off of eBay. And I actually do have a couple more of these devices just sitting around, not being used. And they're very easy to replace. And I'm going to tear this apart anyway, just to put fresh thermal paste on the both the heat sinks. And I'm going to replace this fan with a thermally controlled fan that can ramp up to a very high speed if needed. So anyways, it's going to have a front look at this thing. Okay, here's a look at the front side of this thing, and you can tell that window is pretty dirty. But of course, I'll get that cleaned up after I get this thing working. Good thing to know about this thermoelectric cooler is the cabinet is built very well. Like, let's say the refrigerator in your kitchen. Very, very sturdy cabinet. And have a listen to this. It has the same kind of gasket that the refrigerator in your kitchen would have. So it gets a very good seal. That's what you want to have to keep the cold inside the cabinet. Now, of course, my mini fridge over here has a latch and this very small strip of insulation. It stays pretty cool inside, though. I have to give it that. But if I can get this working, I'll put this in service and put this in storage or do something with it. Anyways, back to this one again. These shelves come right out. I'm going to set them to the side. So that way you could store other things in here. And this thing, I believe it could fit a 2-liter drink pretty easy. And the cool thing about this fridge is it uses an evaporator fan rather than, let's say, what this uses. It's a solid state. Though the solid state works pretty good too, I have to give it that. But this right here circulates the air inside the fridge. It sucks in air through here, pulls it across this cold side heatsink, and blows it through here, and does the same thing through this side too. And it even has a little drain down here. I don't know if you can see or not, but there's a little bitty drain down there. And the outlet is on the outside of the fridge, and I'd have to hook up, let's say, a piece of vinyl tubing and run it to, let's say, a pan or something to collect the water. But anyways, all I gotta do is get this thing working. This will make a pretty nice fridge. Well, not to mention, the display, which runs on 5 volts, even has this little LED light in here. And it lights up a very dim blue, but it actually looks pretty good when you have stuff sitting in here. And of course, I'll probably shoot some video of me working on this thing whenever I get around to it. It's pretty late right now. And I have started the college semester again, fall semester 2012, so I'm not going to have as much time to do my stuff, but I'll get this thing fixed sooner or later. It's another project. Anyways, any questions or comments, feel free to ask. Hey everybody, check out this recent thrift store find that I got. This is a 0.7 cubic foot Haier, or Haier, however you pronounce it, thermoelectric wine cooler. Now of course I'm not going to be using this to store wine. I'm going to be using this as a mini fridge. So anyways, I'm just going to look at the specs. Here's the back panel. Here's the specification label. Tells you thermoelectric wine cellar, It's a model HVUE B06BBB. Capacity is 0.7 cubic feet.